Come witness the amazing heat pipe, brought to you by Team Lienhard, named after the world-famous book written by the two. Team members are Ben Carruthers, Matt Heimonen, and Kyle Sherman.
A heat pipe is an object that absorbs heat from a heat sink and dissipates it to a cold interface. Kind of a fun real-world application of this lies in the Trans-Alaskan pipeline system. Essentially, hot oil is piped through this pipeline, and to preserve the layer of permafrost on the ground, they utilize heat pipes to dissipate that heat.
A working fluid such as water or acetone is placed under a vacuum in order to lower its boiling point. As heat enters in the evaporator section, the working fluid changes to a vapor. The vapor then rises to the lower temperature condenser section of the heat pipe. The heat from the vapor is then released to the surroundings as the vapor condenses to a liquid. Gravity then brings the condensed fluid back down to the evaporator section.
In order to model a heat pipe, we started with an energy balance. Ideally, all of the heat added to the evaporator is dissipated by the condenser, but in reality, the condenser limits the amount of heat that can be transferred. In order to find out how much heat could be dissipated by the condenser, a Nusselt number correlation was used, and from this, a heat transfer coefficient for both the inside and the outside of the condenser could be found. These heat transfer coefficients were used in conjunction with a thermal resistance network, and the total heat transfer rate was found for the condenser. Knowing this heat transfer rate, the total energy dissipated in 15 minutes was calculated, and then it was represented as a temperature decrease of the water.
Heat pipe construction. The components of the heat pipe that we chose were copper and PVC. The copper components were sweated together using a torch and solder to form an airtight seal to continue to hold that fluid under vacuum. Plumbing tape was utilized to fit the PVC and copper together via male and female threads.
Our heat pipe is 29.5 inches tall with a long condenser section to optimize the heat transfer to the surroundings. We added a PVC adiabatic section to reduce the conductive heat transfer from the evaporator to the condenser. We chose our working fluid to be distilled water due to its safety in large specific heat.